The ISO week date system is a leap week calendar system that is part of the ISO 8601 date and time standard that was issued by the International Organization for Standardization. It is used in government and business for fiscal years, as well as in timekeeping. The system specifies a week year atop the Gregorian calendar by defining a notation for ordinal weeks of the year. The Gregorian leap cycle, which has 97 leap days spread across 400 years, contains a whole number of weeks. In every cycle there are 71 years with an additional 53rd week. An average year is exactly 52.1775 weeks long. Months average at 4.348125 weeks. An ISO week numbering year has 52 or 53 full weeks. That is 364 or 371 days instead of the usual 365 or 366 days. The extra week is referred to here as a leap week, although ISO 8601 does not use this term. Weeks start with Monday. The first week of a year is the week that contains the first Thursday of the year. ISO week year numbering therefore slightly deviates from the Gregorian for some days close to the 1st of January. A date is specified by the ISO week numbering year in the format YYYY, a week number in the format WW prefixed by the letter W, and the weekday number, a digit D from 1 through 7, beginning with Monday and ending with Sunday. For example, the Gregorian date the 31st of December 2006 corresponds to the Sunday of the 52nd week of 2006, and is written 2006W52-7 or 2006W527. Relation with the Gregorian calendar. The ISO week numbering year number deviates from the number of the Gregorian year on, if applicable, a Friday, Saturday, and Sunday, or a Saturday and Sunday, or just a Sunday, at the start of the Gregorian year and a Monday, Tuesday and Wednesday, or a Monday and Tuesday, or just a Monday, at the end of the Gregorian year. In the period the 4th of January to the 28th of December and on all Thursdays the ISO week numbering year number is always equal to the Gregorian year number. First week. The ISO 8601 definition for week 01 is the week with the year's first Thursday in it. The following definitions based on properties of this week are mutually equivalent, since the ISO week starts with Monday. It is the first week with the majority of its days in January. Its first day is the Monday nearest to the 1st of January. It has the 4th of January in it. Hence the earliest possible dates are the 29th of December through the 4th of January, the latest 4 through the 10th of January. It has the year's first working day in it, if Saturdays, Sundays and the 1st of January are not working days. If the 1st of January is on a Monday, Tuesday, Wednesday or Thursday, it is in week 01. If the 1st of January is on a Friday, it is part of week 53 of the previous year. If on a Saturday, it is part of week 52. If on a Sunday, it is part of week 52 of the previous year. Last week. The last week of the ISO week numbering year, i.e., the 52nd or 53rd one, is the week before week 01. This week's properties are: it has the year's last Thursday in it. It is the last week with the majority of its days in December. Its middle day, Thursday, falls in the ending year. Its last day is the Sunday nearest to the 31st of December. It has the 28th of December in it. Hence the latest possible dates are the 28th of December through the 3rd of January, the earliest 21 through the 28th of December. If the 31st of December is on a Monday, Tuesday or Wednesday, it is in week 01 of the next year. If it is on a Thursday, it is in week 53 of the year just ending. If on a Friday, it is in week 52. If on a Saturday or Sunday, it is in week 52 of the year just ending. Weeks per year. The long years, with 53 weeks in them, can be described by any of the following equivalent definitions. any year starting on Thursday and any leap year starting on Wednesday, any year ending on Thursday and any leap year ending on Friday, years in which the 1st of January and the 31st of December or either of Thursdays. All other week numbering years are short years and have 52 weeks. The number of weeks in a given year is equal to the corresponding week number of the 28th of December. On average, a year has 53 weeks every 5.6338 years. The following 71 years in a 400-year cycle have 53 weeks. Years not listed have 52 weeks. 004, 009, 015, 020, 026, 032, 037, 043, 048, 054, 060, 065, 071, 076, 082, 088, 093, 099, 105, 111, 116, 122, 128, 133, 139, 144, 150, 156, 161, 167, 172,178, 184, 189, 195, 201, 207, 212, 218, 224, 229, 235, 240, 246, 252, 257, 263, 268, 274, 280, 285, 291, 296, 303, 308, 314, 320, 325, 331, 336, 342,348, 353, 359, 364, 370, 376, 381, 387, 392, 398. These long ISO years are 43 times 6 years apart, 27 times 5 years apart, and once 7 years apart. The Gregorian years corresponding to these 71 long years can be subdivided as follows. 27 Gregorian leap years, 14 starting on Thursday, hence ending on Friday, and 13 starting on Wednesday, hence ending on Thursday. 44 Gregorian common years starting, hence also ending on Thursday. The Gregorian years corresponding to the other 329 short ISO years can also be subdivided as follows. 70 are leap Gregorian years, and 259 are non-leap Gregorian years. Thus, within a 400-year cycle, 27 long ISO years are 5 days longer than the corresponding leap Gregorian years. 44 long ISO years are 6 days longer than the corresponding common Gregorian years. 70 short ISO years are 2 days shorter than the corresponding leap Gregorian years, and 259 short ISO years are 1 day shorter than the corresponding common Gregorian years. Weeks per month. The ISO standard does not define any association of weeks to months. A date is either expressed with a month and day of the month, or with a week and day of the week, never a mix. Weeks are a prominent entity in accounting where annual statistics benefit from regularity throughout the years. Therefore, in practice usually a fixed length of 13 weeks per quarter is chosen, which is then subdivided into 5 plus 4 plus 4 weeks, 4 plus 5 plus 4 weeks, or 4 plus 4 plus 5 weeks. The final quarter has 14 weeks in it when there are 53 weeks in the year. When it is necessary to allocate a week to a single month, the rule for first week of the year might be applied, although ISO 8601 does not consider this case. The resulting pattern would be irregular. The only 4 months of 5 weeks would be those with at least 29 days starting on Thursday, those with at least 30 days starting on Wednesday, and those with 31 days starting on Tuesday. Dates with fixed week number for all years. 8 days have a fixed ISO week number in January and February, and with the exception of leap years starting on Thursday, dates with fixed week numbers occurs on all months of the year. During leap years starting on Thursday, the ISO week numbers are incremented by 1 from March to the rest of the year. The day of the week for these days are related to Doomsday because for any year, the Doomsday is the day of the week that the last day of February falls on. These dates are 1 day after the Doomsdays, except that in January and February of leap years the dates themselves are Doomsdays. In leap years the week number is the rank number of its Doomsday. Equal weeks the pairs 02, 41, 03, 42, 04, 43, 05, 44, 15 28ths, 16 29ths, 37 50ths, 38 51sts and triplets the 6th of October 45, the 7th of November 46. The 8th of December 47 have the same days of the month in common years. Of these, the pairs 10 45ths, 11 46ths, 12 47ths, 15 28ths, 16 29ths, 37 50ths and 38 51sts share their days also in leap years. Leap years also have triplets March 15th 28, April 16th 29 and pairs 06, 32, 07, 33, 08, 34. The weeks 09, 19 to 26, 31 and 35 never share their days of the month with any other week of the same year. Advantages: all weeks have an integral number of days. All years have an integral number of weeks. The date directly tells the weekday. All week numbering years start with a Monday and end with a Sunday. When used by itself without using the concept of month, all week numbering years are the same except that some years have a week 53 at the end. The weeks are the same as used with the Gregorian calendar. Disadvantages: the year number of the ISO week very often differs from the Gregorian year number for dates close to the 1st of January. For example, the 29th of December 2014 is ISO 2015W1-1, i.e., it is in year 2015 instead of 2014. A programming bug confusing these two year numbers is probably the cause of some Android users of Twitter unable to log in around midnight of 29 December 2014 UTC. Solar astronomic phenomena, such as equinox and solstice, vary over a range of at least 7 days. This is because each equinox and solstice may occur any day of the week and hence on at least 7 different ISO week dates. For example, there are spring equinoxes on 2004W12-7 and 2010W11-7. The ISO week calendar relies on the Gregorian calendar, which it augments, to define the New Year day. As a result, leap weeks are spread across the 400-year cycle in a complex, seemingly random pattern. There is no simple algorithm to determine whether a year has 53 weeks without tabular lookup. Most calendar reform proposals using leap week calendars are simpler in this regard, although they may choose a different leap cycle. Not all parts of the world consider the week to begin with Monday. For example, in some Muslim countries, the normal work week begins on Saturday, while in Israel it begins on Sunday. In the US, although the work week is usually defined to start on Monday, the week itself is often considered to start on Sunday. Calculation. Calculating the week number of a given date. The week number of any date can be calculated, given its ordinal date and its day of the week. If the ordinal date is not known, it can be computed by any of several methods. Perhaps the most direct is a table such as the following. Method. Using ISO weekday numbers, subtract the weekday from the ordinal date, then add 10. Divide the result by 7. Ignore the remainder. The quotient equals the week number. If the week number thus obtained equals 0, it means that the given date belongs to the preceding year. If the week number of 53 is obtained, one must check that the date is not actually in week 1 of the following year. Example: Friday the 26th of September 2008, ordinal day, 244 plus 26 equals 270. Weekday, Friday equals 5. 270 minus 5 plus 10 equals 275. 275 sevenths equals 39.28. Result: Week 39. Calculating a date given the year, week number and weekday. This method requires that one know the weekday of the 4th of January of the year in question. Add 3 to the number of this weekday, giving a correction to be used for dates within this year. Method: multiply the week number by 7, then add the weekday. From this sum subtract the correction for the year. The result is the ordinal date, which can be converted into a calendar date using the table in the preceding section. If the ordinal date thus obtained is 0 or negative, the date belongs to the previous calendar year, if greater than the number of days in the year, to the following year. Example: year 2008, week 39, Saturday. Correction for 2008. 5 plus 3 equals 8. Plus 6 equals 279. 279 minus 8 equals 271. Ordinal day 271 of a leap year is day 271 minus 244 equals the 27th of September. Result: the 27th of September 2008. Other week numbering systems. For an overview of week numbering systems, see week number. The U.S. system has weeks from Sunday through Saturday, and partial weeks at the beginning and the end of the year, i.e., always 53 weeks. An advantage is that no separate year numbering like the ISO year is needed. Correspondence of lexicographical order and chronological order is preserved. But partial weeks make some computations of weekly statistics or payments inaccurate at end of December or beginning of January. A variant of this U.S. scheme groups the possible 1 to 6 days of December remaining in the last week of the Gregorian year within week 1 in January of the next Gregorian year, to make it a full week, bringing a system with accounting years having also 52 or 53 weeks, and only the last 6 days of December may be counted as part of another year than the Gregorian year. The U.S. broadcast calendar counts the week containing the 1st of January as the first of the year, but otherwise works like ISO week numbering without partial weeks.